Thank you very much all for being here once again. We are in the fifth seminars of this Lunch Talk series, the second Lunch Talk series. Today we have with us two special persons with us. One is José Ramón Aira, that will act as moderator, and our important presenter will be Evelyn Grillo. They will talk about buildings and climate change without the changes in architecture and construction. So as always, I hope you enjoy this meeting. It will be nearly the last, just the last week will be the last one. And I will give the floor to Professor José Ramón. So thank you, all of you, for being here.
Thank you, Alvaro. And hello, everyone. Today, as Alvaro said before, today begins another talk of the Lunch Talks initiative about exploring urban sustainability. Today's sessions is entitled Building and Climate Change, Challenges and Architecture and Construction. This event takes place with the context of EELISA Discovery Community, to which both today's speaker and myself belong. My name is José Ramón Aira. I am an associate professor in the Department of Architectural Construction and Technology at the School of Architecture of the Technical University of Madrid. Specifically, I teach the subject of construction materials, where we study in depth the properties of materials and products, not only materials, also products, some of which are related to today's talk, such as, for example, thermal, optical, or acoustic properties. I also teach subjects related to wood as a material, such as timber construction, structural design, or even pathology of wooden structures, of wooden elements. Wood, as you know, is a natural and ecological material, is an eco-friendly material that is currently very much in line with the use of efficient and low energy materials in architecture. So it's a pleasure for me today to introduce today's speaker. Her name is Evelyn Grillo. She's an architect and she's currently studying for her PhD at the Mediterranean University of Reggio Calabria. She develops a thesis aimed at the definition of an adaptive model for the mitigation of temperature rise for a curtain wall system. She belongs to the research group of the TC Lab section of the Building Future Lab, which is a laboratory for testing and experimentation on building envelopes, scientifically responsible Professor Milardi. And her research activities focused on the technological and material performance of the building envelopes, investigating its potential for adaptation to climate change. In this section, then future trends and adaptive system for building envelopes will be discussed with this objective offering dynamic and programmable responses capable of managing the operation of the building for real energy efficiency and control of living comfort in the face of ongoing climate change. So without further delay, I leave you with Evelyn, with the architect Evelyn Grillo. So you have the talking, Evelyn, when you want.
Thank you, Professor, and I would like to thank to the Professor Gutierrez and Olivieri for inviting me to this series of seminar. And can I share my screen now?
Yes, sir. Go for it. No.
This seminar, I will focus on the issue and climate change and the consequence. Thank you. That of human activities and the built environment. In fact, future trends of adaptive system for building envelope will be discussed, which the aim to offer dynamic and programmable responses capable of managing the energy efficiency and control of living comfort in the face of ongoing climate change. Already since the early 1990s, global transformation has begun, but what once appeared to be a linear progression of change seems to be fading as several revolution are simultaneously underway to transform the strategic changes facing the European Union. In fact, the issues are interconnected. The transition must be ecological, digital, social, and economic, and the environmental issues has to be interpreted from a technical perspective, and innovation will dominate the scenarios of a change. And in addition to this, the dynamic of coexistence of a pandemic with COVID, the emergency therefore accelerated the phase of the transformation already underway. And for this reason, the climate change is a very important challenge for human life. The scientific studies state that throughout the geological areas, the climate change according to natural cycle, but the variability we are experiencing now is on a time scale of decades rather than millennia. In fact, from 14th to 19th century, with the light ice age, temperature dropped by 2 degrees Celsius. And but it was with the Industrial Revolution that the climate system underwent much more abrupt change. In fact, recent measurements of the concentration of CO2 in the atmosphere show the records of 418 parts per million and 15% increase over the period 1750 to 1811. And according with the report Global Carbon Budget, the highest share of concentration of CO2 emission are due to coal extraction of fossil fuel such as oil, gas, and the production of material, glass and cement. But the overall picture of CO2 emission states that 3/4 come from energy consumption. In fact, buildings are a major contribution to greenhouse emission, and no action plan can succeed without addressing this key sector. In fact, according to the latest IPCC report, the temperature will rise about 1.5 degree Celsius by 2014, leading to an increase in temperature and change in the variation in precipitation. Are calculated through mathematical models, identified for climate scenario from least to the most severe, based on concentration of CO2 emission, which will continue to rise, causing a rise in sea temperature, melting glaciers in the northern hemisphere, and altering the pH of the progressive extinction of some marine species. And I wanted to show a focus in Mediterranean area. In fact, moving in this area, that is the climate context that I also take into consideration in my doctoral thesis, which I want to explain now, but I just wanted to say that the aim of my thesis is develop an adaptive model for curtain wall to cope with rising temperature in the Mediterranean area. And from the studies carried out on climate change in this area, using Adapteca or IPCC simulation software, it can be seen that in the worst case in RCPH 0.5, the variation of temperature in August, an increase of 2.3 degrees Celsius is expected in the 2030, and for the precipitation, a decrease of 3% in month of March. And for this reason, the rising of temperature are therefore an issue to be taken into account for new building or for retrofitting of existing building. That's a phenomena of climate change reverberate on city, on built environment, and since the cities are made up of buildings, it is the building envelope that risk the most damage from increasingly frequent extreme phenomena such as fire, flood, tornado, and the actual Medican. The term means Mediterranean hurricane. It is a cyclone that developed in the Mediterranean area, sea, and has a certain characteristic as a hurricane. And building can be vulnerable to climate change, and in the future there could be an increased risk of collapse or a decline in health and a significant loss of temperature and performance, such as water infiltration and increase internal heat due to an increase in the rainfall and rise in temperature in the near future, 2030 to 2040. And for this reason, there is a need for transformative action that implement a real solution and not just a programmatical and instrumental policy lines. Since buildings contribute to a direct feedback on the share of emission, and the answer to the issue is linked to the control of the energy efficiency through the mitigation and adaptation action, with the aim of intervening at the project level in line with the changeable environmental condition. This highlights the new role of the building envelope. That is a complex system of elements, components, which has gone from being a static barrier to becoming an osmotic membrane capable of controlling and regulating its operation of the basic transient external stresses, and the user need. The envelope now acquired more responsive, dynamic, interchangeable words which have as their common denominator the innovation of technological system and material. But in general, the adaptive behavior is given by the combination of sensor and movement mechanism that can be classified into hydraulic or pneumatic electric motors. And we will see example of adaptive building envelope. The expo thematic pavilion is an adaptive cinematic facade consisting of 100 fiber reinforced plastic panels through a system of actuator where there is a wide pressure sensor control the position of these elements and transmitting the opening and closing response to a servo motor, which control this adaptive movement. But an important characteristic of this adaptive envelope are the photovoltaic panels are integrated into the roof landscape to generate solar electricity, providing about 2/3 of the energy consumed by the building system over the year. Another example are the Bauer towers in Abu Dhabi. This example is an emblematic of adaptive envelope based on Mashriba, a screen that adapts to the movement of the sun, providing protection to the sunrise by optimizing the emission of a diffused light. This dynamic facade is characterized by a series of hexagonal material of PTFA insert is operated by a linear actuator. This structure is controlled by a software that monitors the position of the sun, ensuring that the facade and these technologies for design for the facade make it possible to reduce the internal temperature by 50% with a significant reduction in consumption. And another example I propose is the Media ICT building in Barcelona. This adaptive building envelope uses a skin composed by air chamber which inflate or deflate as the light changes. The mechanism is controlled by a digital light sensor, reducing the thermal flow of ultraviolet rays by 85%. And the protection from the outside heat is achieving used what's known as the diagram configuration of cation, whereby 3 layers of plastic square frame and inflated a pillow. The resulting bubble contains up the 3 air chamber that together create an adaptive shade effect and provide thermal insulation for building. And while the disappearance for the necessary balance between man and nature seems to have been taken for granted by the strong anthropic nature and the built environment, a new approach, the biomimetic architecture, is now based on the concept that is possible to imitate, to replicate natural functions and behavior, create more efficient system components for building envelope. Jamie Menus said that the nature as a model, mentor, and example that to be explored and investigate. For example, the material Velcro, made up in 1914 by engineer George de Mestral, imitates flowers stuck in his dog's fur. And this innovative is based on technology, biology, and engineering. And for the building sector is important because understanding the workings of living organisms and applying them to the human creation enables the development of solutions that not only limit the environmental impact of product and system, but also improve the performance and reaction with a new greater adaptability. We will see 2 examples of biomimetic adaptive facade. The big house in Hamburgo is the first powered by algae, which grow quickly when the sun is shining and providing more shade for building. And the bioreactors and not only produce the biomass that can be stored, but also capture the building. This means that photosynthesis drives a dynamic response to the amount of sun protection needed, while the microalgae growing in the glass panel of the facade and became a new resource of renewable energy. And the Flectofine is a biomimetic shading for facade based on the behavior of a flower Sterlitza regina, made of glass fiber panels, applying a pressure such as a wind generates a flexion that causes the opening and closing of the facade. But this strategy, overall strategy, aimed at the efficiency in the construction sector and are increasing the oriented towards the innovation of the material with low environmental impact. But by adopting a circular economy model, the aim is to minimize the waste generation and maintain the value of products within the system as long as possible. And the shift from linear to circular is to in response response to the need to combine innovation, competitiveness, and environmental sustainability through reuse, recycle, and creating new products. And the efforts of the research and the experimentation in this field define different materials, so-called emerging materials. For example, the experimental wood-based material refers to materials that are processed with mechanical from trees for an innovative application. For example, the biocomposite pavilion is a double curved shell of wood and biocomposite elements that include cellulose fibers extracted from barks. The advanced growing material are material grown by living organisms such as fungi, bacteria, and algae. And startup Mogu in Italy produce a material made up from the mycelium of fungi and the various industrial waste materials producing thermal and acoustic insulation and flour. Other materials are nanomaterials, are those materials whose size is between 1 and 100 nanometers, and one example of this is a homeostatic facade, which consists of thermobimetal elements that react to the different temperature through intrinsic control. Other materials are interconnected, which include hybrid material systems that are able to transfer and receive information not only the internet and digital network, but this material are able to respond contextually and reversibility to external stimuli, changing their property and qualities. For example, active protection system is constituted by an intelligent materials because it responds to a changing variation within this environment. For example, within an impact force, the material stiffen instantly, and when the impact has passed, the material immediately becomes flexible again. And the sensitive fabric consists of two side elements separated by the electric elements, and the effect is that with the pressure on this material, the face go touch and close this electrical circuit. Other experiments of new technologies of the future for reduce the environmental impact involve two important Italian industry company. The first is Rice House company, which focus on exploiting by the products of rice cultivation ducts as a innovation through the product of building materials such as bricks, paints, plaster, and rice from secondary raw materials became a resource in the construction sector. Example, Archicart company produce wall and structure panels with corrugated cardboard that are assembled not with the use of not recyclable material. This panel can be used to create contemporary space structure due to their lightness, isolation, and can be dismantled and reassembled if. But to put a system of, and for the verification of the performance of this system, the market, it has two performance requirements, high stringent industries regulations such as air permeability, water tightness, seismic performance, and these requirements that the building envelope must guarantee even in the face of climate change. And measuring the performance of building envelope is possible thanks to advanced laboratories such as Teach Lab, where I work, and the laboratory is one partner of Metabuilding Lab and of Horizon. Develop an innovative system solution for next generation of building. The most important characteristics of this laboratory are the machine, the instrument to simulate the effect of climate change, verifying the performance of the components and the materials that make up the architecture or envelope. For example, test lab, test room, can be divided into two parts to allow comparative analysis between mock-up and the particle of this chamber of the system is important for the flexibility in the geometry, the different linear curve data. The fan is capable to generate the wind speed from 210 hours. The grid for water consists of a series of loops with nozzle, the thermal chamber for the thermic characterization of building envelope, and some experimental tests conducted in laboratory. For example, the experimentation was carried out by a wind flow with in the first figure through American protocols, which gets the power of a hurricane, which allow with the verification of the performance behavior of curtain wall Kappa company. The impact test with the structural performance opaque mock-up of Tishika company, and for pluvial flooding, the experimentation was carried out by a constant rain directly to the facade of the linear or curved mock-up, and test cell, the thermodynamic characterization envelope in the real scale research that the patenting of thermal frame of trans door, and solution in this sense of the construction sector process is as an adaptive climate change based on development and performance evaluation with respect to and real environmental context. thank for your attention, and I hope I was on time.
Thank you very much, Evelyn. Your speech was really inspiring and really interesting for us. So I don't know,
Hear me?
is there, yes, is there any question from our assistants, from our participants? Well, while they are thinking, I ask you one question. The aim of your PhD studies, Evelyn, is to develop an adaptive coaching work system for the problem of temperature rise as a consequence of climate change. Okay, no, and specifically, what materials are you going to use in this manufacture in your PhD studies? What material?
Thanks for the question, Professor. The objective of my thesis is to define an adaptive model through the use of innovative material. The model can be applied to curtain world, understood as an element vulnerable to the effects of extreme events in the Mediterranean climate, and in particularly more stressed by external energy flow. Research efforts, in fact, are focused on the choice of the most suitable materials to define the level of adaptability of the model and its technological characterization. And as we've seen, there are two types of adaptation of building envelope. The first of these, the variability of which is linked to the variability of the geometry of the model, or using mechanism system such as actuators, linears, or pneumatic actuators. And the second, the variability of which is linked to the intrinsic property of the material of which they are made. In my study, in fact, having to respond to the climate problem of rising temperature, I analyzed those materials that regulate their adaptivity behavior through strategies based on material properties, including changes that directly influence the internal structure of materials, such as a different temperature. For example, material hybrid shape memory material, which consists of a shape bimetallic strip with different coefficient, thermal coefficient expansion, allowing shape change in order to respond of different temperature, or electroactive polymer materials whose dynamic behavior is triggered when an electric current, a stimulus, external stimulus, flows through the laminate, increasing the electrostatic force that generate a contraction on expansion of this element. And an example I show you earlier is the homeostatic facade, in which these polymeric materials open and close depending on the heat flow. This material I prefer to use material that change behavior with an intrinsic comportment behavior.
So you are focusing on intelligent materials, no, not natural, yes, or plastic, just intelligent materials from every family, yes, no? Okay, okay, thank you.
Yes.
Okay. So another question for you. An adaptive behavior, is provided by a combination of sensors and actuators, sensors,
See,
actuators,
yes.
pneumatic, hydraulic, or electric motors that respond to data collect by the sensors you place on your wall, on your curtain wall. Yes. So, do you consider the permanent implementation of any renewable energy generation system to power those devices, the sensors and the actuators to power those devices? Do you consider any renewable energy generator?
Thanks. And at this moment, we have not through about implement a renewable energy generation system to power this device, because we plan to develop the adaptive model with materials that not use mechanism of the system, such as actuator, but we could implement a system that absorb the solar energy that the adaptive material is able to collect, and use this heat if necessary for the reuse of energy and minimize the consumption of electrical system. And the verification of these adaptive models with American or European normative will be carried out at the Teach Lab section with the aim of developing prototype line that can facilitate the new approach of high environmental quality of building of adaptive building envelope. I hope I have answered your questions.
Yes, of course. Yes. It's just a question on my mind. So I don't know if is there any question from our participants, for the participants of the meeting. If anyone wants to have a question, please put your hand up, or just speak with Evelyn, who is eating perfectly. I think there is no problem with the microphone. So let me see. Let me test.
The students contact me by email. I don't have problem in other moment to explain other themes or themes that I explained in this session. Don't have a problem.
Okay, so I think we are we are on time, and I'm going to finish the session. But before ending the meeting, before ending the session, I would like to say thanks to Evelyn, to the speaker, for her brilliant intervention. Really inspiring, really inspiring. And thank you very much to all of the participants. And I hope that this session has been useful for us to thinking about this important topic, because it's really important to the next years for all of us. Okay, so if I think there is no more questions, so finish this session. Really thanks, Evelyn. Really thanks, and have a nice day to everyone.